Alright guys, today we're going to be looking at section 5.5, exponents in scientific notation. So we're going to look at our exponents rules first, and then we'll look at scientific notation. Okay, so just to refresh your memory on some terminology, if we're looking at a number, which is a to the n, a is the base, and n is the exponent. Okay. Alright. Then for your rules for exponents, we have the product rule, we have the power rule, we have the quotient rule, and then we have a to the 0 power, and then we have using a negative exponent. So if you can't see that that's a negative in there, you might want to make it a negative down there. Okay. So those are the things we're highlighting, so I can put this away. Alrighty. So, product rule. If you are multiplying two things that have the same base, you add their powers. So when you're multiplying, add powers. This is what back when I taught Math 1, I taught this as a piggyback power because it looks like the n is writing on the back of the n. But it's a power rule, so when a power is raised to another power, so power on power, you multiply powers. Okay, so if you're multiplying, you add the exponent. So what do you think you do when you divide? You subtract the exponents. Good. So dividing, you subtract powers. And again, this should all be review. Anything to the 0 power is 1. And then if you have a negative exponent, what you do is take this whole piece and drop it to the bottom. It becomes a positive exponent, and then you put a 1 on top. Okay? So I'm going to take a minute and write this down in words. Anything to the 0 power equals 1. Alright. This one is when you have a negative exponent. You drop to denominator and exponent becomes positive. The coefficient of original problem is the numerator. And what I mean by this, if there was a 3 in front of that a, then the 3 would be your numerator. Since there's nothing there, there's an understood 1. That's why you put a 1 there. Okay? Alright. Another thing that I want you to remember, if you have a negative number and it's raised to an even power, then your answer is going to be positive. If you have a negative number and it's raised to an odd power, it's going to be negative. So that way, like if you have a power of like 14, you don't have to sit there and can't figure out if it's positive or negative. So even powers on a negative make it positive, and odd powers make it negative. All right, now, moving on to scientific notation. A number is written in scientific notation if it's of the form a number times 10 to a power, where the number is bigger than 1 or bigger, and less than 10. Okay, so that means up to 9.9999999. Okay, so how do we do scientific notation? So, where did my red pen go? That's very strange. Oh, there it is. So, if the number is very large, let's say the number is 2,345,678. And we want to put that in scientific notation. Okay? Then what we're going to do is we're going to leave one number in front of the decimal point. You're going to put all the rest of the numbers behind the decimal point. Then you're going to count, because normally your decimal point's back here. So we need to figure out how many places did we move to get right here. And we went 1, 2, 3, 4, 5, 6 places. So that's how we know what the exponent should be. Okay? If the number is very small, let's say it's 0.0, 1, 2, 3, 4, 5, 6, 7. Okay, let's say that's our number. You have to move it to a number that's at least 1. So that means we're going to move it to right here. And it's 1 point, all the other numbers. And how many places did we move it? 2. Because this is a small number, it's a negative exponent. Okay, just to refresh your memory on scientific notation. I know you probably haven't done that in a while. All right, so we're going to do some practice problems. Okay, here we go. So evaluate. I'm going to do some basic exponent problems. Okay. Now, again, you're only going to have your baby calculator. So what you're going to have to do is do 5 times 5 times 5 times 5. That's 625. Zero to the third power. So that's 0 times 0 times 0. So that's 0. Now, this says -5 squared. So we have a negative number that we are squaring. So this is going to be a positive. And 5 squared is 25. Now, this looks similar but different. The negative is not being raised to the power, only the 5 is. Okay, so we're going to put a note here. Only 5 is being squared. And we'll put a note here. -5 is being squared. Okay, so 5 squared is 25, and you have the negative sign. So be very careful when the negative is in the parentheses, it becomes positive. If it's not, it just stays there because it means the opposite of 5 squared. All right, next. The directions for this says use the rules of exponents to evaluate. So we have -2 to the third power times -2 to the third power. Now, what we're going to use is the product rule. Okay, they have the same base. So this is going to be -2 to the 6. So we add our powers. Now, to even number is going to make it positive. So then we can just do 2 times 2 times 2 times 2 times 2 times 2. And that's going to be 64. Okay. Problem 6. 8 to the 0 times 8 squared. All right. So you're going to do the product rule again. And that's going to mean you add. So that's 8 squared. 8 squared is 64. Problem 7. 3 squared to the 4. Okay, this one's a power rule. Remember, with power rules, you multiply your powers. So that's 3 to the 8th. So we do 3 times 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 3. And that's 6,561. Now, let's do number 8 right here. -3 to the 6th over -3 to the 9th. Okay, this one's a quotient rule. Okay, so that means we subtract our powers. So 6 minus 9 is -3. Okay, so now we have a negative power. So negative exponent. Remember what we do with a negative exponent. It drops down and it becomes a positive power. Now, remember, with an odd, that's going to be a negative. So 3 times 3 times 3 is 27. So this is 1 over -27. All right. And problem 9. I'm going to put a little star here. Okay, if we're supposed to use the rules to help us, the first thing we have to do is manipulate this one. We need to have the same base. And in this last problem, we could see that 3 cubed is 27. And we know that 3 squared is 9. So what we're going to do is make this 3 squared, which is 9. And we have that 3 on the outside. Then we know that 3 cubed is 27. And we have 2 on the outside. So now we have the power rule, which means we're going to have 3 to the 6th times 3 to the 6th, which is now a product rule. So we about used all of our rules in this one. So that's 3 to the 12th, and just for the sake of time, that's 531,441. Okay. Now, the next piece we're going to write in scientific notation. Okay. So we have 3, 200, 0, 0, 0, 0, 0, 0. Alright, so remember we keep one number in the front, and you do not have to write all those zeros, okay? Only like actual numbers. Now, if there was a random 1 right here, yeah, you would have to write all those zeros. So we have 3, 6, 9 places here. So 10 to the 9th. And we have 0.000258. Okay, so the first number I see is the 2. So we have 58. Now this was a small number, so we know that the exponent's going to be negative. So we move it 1, 2, 3, 4 places. All right, next we have 28. To put that in scientific notation, one number in the front, 2.8. How many places did we move it? Just 1. $13, 8,056. So we have 8.056, and we moved it 3 places. Now, watch these two. 426.5 times 10 to the 5th. So it's not fully in scientific notation. I need to move it an additional 2 places. Okay, an additional 2 places. They did not go far enough. So those 2 places are going to make it times 10 to the 7th. And this one, 0.03 times 10 to the 8th. Now I'm going to have to move it back 2 places, and it's becoming a negative, so that means I need to subtract 2 places. So when I take off 2 places, that's going to become to the 6th power. All right. Let's see. I'm going to do 2 of these. Write in standard notation. Okay, so 16 is 4.7 times 10 to the 8th. So that means I need to move this decimal 8 times, and I'm making a big number. So this is 4, 7, and then I go, that's 1 place, and then I need 2, 3, 4, 5, 6, 7, 8. When I put my commas in there, that's 470 million. Okay, let's do a small one. 7.41 times 10 to the negative 8. Okay, so we're going to need to move this and make it a small number. We're going to move it 8 places. We have 1 place, so we need 7 zeros. So 0.0, 0, 0, 0, 0. How many is that? 1, 2, 3, 4, 5, 6, 7. 7 zeros. 7, 4, 1. Okay. Alrighty. Now, I'm going to write this, the directions, in black, and then I'm going to work it in blue. So use scientific notation to solve. Leave in scientific notation. Okay, so the way you work these problems, so problem 18, we have 4 times 10 to the third. We're going to multiply it times 2 times 10 to the fourth. So the way that we work these is we do 4 times 2, so you multiply the whole numbers, and then you multiply the tens portion together. Okay, so we know that 4 times 2 is 8. And then we add the powers. So this is 8 times 10 to the 7th. Okay, so for 19, we have 4.8 times 10 to the 4th divided by 1.6 times 10 to the 3rd. So again, we're going to take 4.8 and divide it by 1.6, and then we're going to do 10 to the 4th divided by 10 to the 3rd. So I'm going to take a minute right here and write product rule here. We're going to write quotient rule here. Okay, 4.8 divided by 1.6 is 3. And 4 minus 3 is 1. Okay, we have one more. $1.4752 times 10 to the 2nd times 5.7 times 10 to the 4th over 4.61 times 10 to the 3rd. So what we're going to do is work the top like we did here, and then that answer over this will be like this piece. Alright, so we're going to take this in stages. So we're going to work the top first. So we're going to do 1.4752 times 5.7, and we'll do 10 to the 2nd times 10 to the 4th. Okay. And this is product rule. So this is going to become 8.40864 times 10 to the 6th. And then we're going to have it over 4.61 times 10 to the 3rd. And we'll come over here. We'll do 8 0.40864 divided by the 4.61. Then we'll do 10 to the 6th minus divided by 10 to the 3rd. And this will be quotient. So this is going to give us 1.828 times 10 to the 3rd. And that would be my answer. And if for some reason it gave you a wonky number with 2 numbers, then you would fix it like you did these back here. Okay, to put it in scientific notation. And that is all for today. Thanks, guys. Have a great day. If you have any questions, let me know.